Hello everyone, my name is Patel Vij and today I am going to present my topic on elevator control system using sequential circuit. Elevators are something we use almost every day in malls, offices and apartments. But behind this simple system there is a very intelligent control mechanism working continuously. In this presentation, we will understand how sequential circuit we use to design an efficient and reliable elevator system. To elevator system. First, let's understand what an elevator system is. An elevator system is an electromechanism system that carries passengers between floors. But the challenge is not just moving up and down. The system must handle multiple requests at the same time, decide direction, remember pending calls, serve them efficiently, the require memory and decision making capability which cannot be handled by simple circuits. That's why we use sequential circuit which can store past information and make decision accordingly. Now move forward. What is sequential circuit? A sequential circuit is a type of digital circuits where the output depends on current inputs and previous state. This is the key difference from combinational circuit where output depends only on inputs. Sequential circuits use components like flip-flops, registers, latches. This element allows the system to remember past events, which is essential for systems like elevators. Slide 4. Type of sequential circuits. There are two types of sequential circuits. One is synchronous circuits, which is operated using a clock signal. State changes at specific time intervals, easy to design and reliable, used in elevator system. Second is asynchronous circuit. No clock signal react immediately to input changes, faster but more complex and less stable. In elevator system, we mainly use synchronous circuit because they provide predictable and safe operation. Slide 5. Why sequential circuit in elevators? Now let's see why sequential circuits are important in elevators. An elevator needs a memory of requests. It must remember all floor calls until they are served. Direction control. It must continue moving in one direction until all requests in that direction are completed. Flow tracking. It must know its current position at all time. Priority logic. It must decide which floor to serve next. Door control. Door must open and close safely. All these features require state-based logic which is provided by sequential circuit. Now slide 6. Working of elevator system. Let's understand the working step by step. A user presses a floor button. The system checks the current state. It decides the next target floor. The motor moves the elevator up or down. When a target floor is reached, door open. This process repeats continuously until all requests are served. The system also follows an efficient strategy. It serves all requested in one direction before changing direction. Now slide 4. Block diagram. Now let's look at the block diagram. The system has three main parts: inputs, controller and output. In inputs, floor buttons, cabin buttons, sensors, and controller, state register, priority encoder, director control, door timer. In output, motor control, floor display, door motor. All these components are connected through a feedback system to ensure continuous operation. Now move forward. Component used. Now let's see the key component. D flip-flop, which is used to store current state. JK flip-flop, which is used control direction. Counter, which is tracks floor numbers. Priority encoder, which is select next floor. Operator, which is detect when target floor is reached. Sensors, which is provide real world feedback. These components work together to create a complete elevator control system. Now slide 9. State diagram. The elevator can be represented using a state diagram. Each floor is a state. Floor 1, which is state 00, floor 2, which is state 01, floor 3, which is state 10, floor 4, which is state 11. Transition occur based on condition like move up if there is a request above, move down if there is a request below, stop when a target floor is reached. This helps designing and analyzing the system logically. Now slide 10. Advantages. Sequential circuit based elevator system have many advantages: efficient service on floors, reliable memory, easy to expand for more floors, safe door operations, predictable behavior, low cost implementation. Now, limitations. However, there are some limitations. Complex design for many floors, hard to modify one build, no advanced scheduling, limitation for detection, not suitable for large buildings. That's why modern systems often use microcontroller instead of pure hardware logic. Now, in conclusion, to conclude, the elevator system is a perfect real world example of a sequential circuit. It shows how memory, logic, and state work together to control a system efficiently. Understanding this concept help us build a strong foundation in digital electronics, embedded system, computer architecture. Thank you.